Welcome back everyone to my channel Chemistry Made Simple for Neet. I am Dr. Radha Subramaniam with a PhD in Chemistry. So before moving on to the unit Electrochemistry, I will be just giving you some information about the weightage of Neet chapters from Chemistry. So I had many students asking me doubts regarding the weightage of different questions coming for Neet 2022 from Chemistry. So we will be just briefly going through the weightage of different chapters. So firstly, the chapter basic concepts of chemistry comes. So that will be around 2% weightage. Then next is structure of atom, which is 3%. Classification of elements and periodicity in properties will be around 3% weightage. Chemical bonding and molecular structure around 5%. So likely more questions come from this chapter every year. And states of matter, gases and liquids 2%, solid state will be 2%, thermodynamics, it is a very important chapter and around 9% weightage is there for this chapter. For equilibrium it is 6%, redox reaction that is only just 1% and solutions will be 5%, electrochemistry is 4%, chemical kinetics will be 3%, surface chemistry 1%, but sometimes around 2% weightage will be there. And general principles and process of isolation of elements will be only 1%, hydrogen is 3%, S block elements alkali and alkaline earth metals will be 1%, some P block elements 1%, D and F block elements is 4%, coordination compounds 4%, organic chemistry some basic principles and techniques would be 2%, hydrocarbons 3%, haloalkenes and haloarenes is 1%. Alcohols, phenols and ethers very important chapter, it is having around 8% weightage. And aldehydes, ketones and carboxylic acid would be 3%, organic compounds containing nitrogen is 1%, biomolecules 3%, it is a very easy chapter and scoring one also. Polymers also it is very easy, 3% weightage is there. Chemistry in everyday life 4%, environmental chemistry will be 1%. So that is all regarding the weightage of different chapters from chemistry for the NEET exam. Now we will move on to the today's session electrochemistry. Already I have uploaded part 1 of this chapter. Those who haven't watched that unit can see that and come again to part 2. So we will just start with the important concepts from this lesson. So already we have learned many important portions from this lesson. So today we will have a few more points, important points regarding various conductivity, magnitude of conductivity. It varies a great deal and depends on the nature of the material, and also temperature and pressures are two other major factors where the magnitude of conductivity depends upon, and on the basis of this measurements are made. And materials mainly it is classified, all of you know, you already have learned all these concepts in the smaller classes like conductors, insulators, semiconductors and all that, depending on their conductivity. You know what are conductors? They are good, they facilitate smooth and free transmission of electrons or movement of electrons, whereas insulators they do not permit conductivity of electrons at all or charges, whatever it is. Then metals and their alloys, they have very good and large conductivity. So that is why metals we call them good conductors. And certain non-metals like carbon black, graphite and organic polymers, they are all electronically conducting. So even though they are non-metals, these are exceptions, they conduct electricity little bit electronically. Then substances like glass, ceramics, etc., their conductivity is very low, and since it is almost a negligible conductivity, we call them insulators. Then various other substances like silicon, doped silicon, gallium, arsenide, they all have conductivity between conductors and insulators, that is intermediate. They do neither behave like conductors or insulators, in between. So that is what we call as semiconductors, and these are important electronic materials, in TVs and electronic gadgets and all that we use it. Certain materials called superconductors, by definition they have got zero resistivity and infinite conductivity, they do not offer any resistance at all. So such materials we call them superconductors. Now earlier only metals and alloys at very low temperatures, that is 0 to 15 Kelvin, they were known to behave like superconductors, but nowadays Number of ceramic materials and mixed oxides are also known to show superconductivity at high temperatures like 150 Kelvin. Now, electrical conductance through metals, we call it metallic or electronic conductance, and why it is happening? It is happening due to the movement of electrons. So, what factors does electronic conductance depends on? Mainly 3 factors. First, it is nature and structure of the metal. Then secondly, the number of valence electrons. You know what is meant by valence electron? That is the number of electrons in the outermost orbit of an electron. So, you know, if it is 1, 2, number of valence electrons are 1, 2 or 3, then it is metal. Metals, as you know, they are good conductors. Then temperature, normally it decreases with increase in temperature. Okay, now next, how do you measure electrode potential? What is the way to measure electrode potential? So, the potential of individual half cell, we cannot measure it. We can measure only the difference between 2 half cell potential, which gives the EMF of the cell. Now, we choose arbitrarily the potential of one electrode, that is one half cell, then that of the other can be found out with respect to the first half cell. According to convention, half cell called standard hydrogen electrode, which you represent by PTS, hydrogen, H plus aqueous. This is assigned a 0 potential at all temperatures. Now, according to this reaction, that is H plus electron gives half H2. Then the standard hydrogen electron consists of a platinum electrode, which is coated with platinum black, and we dip this electrode in acidic solution and pure hydrogen gases bubble through it. Concentration of both the reduced and oxidized form of hydrogen will be always maintained at unity. Remember, this is an important point, and this shows that hydrogen pressure, that is 1 bar, and concentration of hydrogen ion in the solution is 1 molar. That is why we call it unity. Okay. Now, we will move on to voltaic cell. There are so many types of cells, voltaic cell, galvanic cell and all that. Now, what is voltaic cell? A typical cell, it looks like this. Always oxidation will happen at the anode and the reduction will happen at the cathode. You can see here, then zinc anode and copper cathode, and here we have got a bridge, then voltmeter is connected along with the switch, and this direction shows the movement of cations, and here the red arrow shows the movement of ions. You can see the equation here for the anode. Zinc forms zinc 2 plus 2 electron, whereas here at the cathode copper 2 plus will lose 2 electrons to form copper element or copper metal. Okay, now you know, when the electron enters at one end and it goes out through the other end, the composition of the metallic conductor will not change, it remains the same, and the mechanism of conductance through semiconductors will be more difficult or more complex. And as you all know, pure water has very small amounts of hydrogen and hydroxyl ions, so it lends to very low conductivity. When electrolytes are dissolved in water, they will give their own ions in the solution and increase the conductivity like that. The conductance of electricity by ions, which is present in solution, we call them electrolytic or ionic conductance, because the conductance is happening due to ions, we call them ionic conductance. Then the conductivity of ionic solution depends on some factors which is given here. Firstly, it is the nature of the electrolyte added. Secondly, the size of the ions produced and their solvation. Thirdly, the nature of the solvent and its viscosity. Fourth one is concentration of the electrolyte. Fifth is temperature, that is, it increases with the increase in temperature. And when you pass direct current through ionic solution for a long time, it changes its composition due to electrochemical reactions. Okay, hope you understood. This is very easy, and I have included this as a very simple note, so that even if you want, you can take a screenshot of this for your reference. Now, you know that E cell, it is an intensive parameter, but delta Tg, it is an extensive thermodynamic property, and the value depends on N. You have got a reaction like this here. Just look, zinc plus Cu2 plus gives zinc 2 plus copper. Now, here delta Tg, that is minus 2 Fe cell, and when you write the reaction like this, then the equation changes like this. Okay. If the concentration of all the reacting species, if it is unity, then what will happen? E cell is equal to E minus cell, and we have delta Tg minus is equal to minus NFE cell. This emblem is here, and from the measurement of this you can get an important thermodynamic quantity which is called the standards give energy of the reaction. You denote it like this. From this factor you can find out the equilibrium constant by using this equation. Do write this equation and learn. This is very important even for solving of sums and all. For NEET exam, this equation will be useful to you. Okay, now what are electrolytic cells and electrolysis? Now, electrolytic cell, it is an external sort of source of voltage which is used to bring about a chemical reaction. And simplest electrolytic cell has 2 copper strips which is dipped in aqueous solution of copper sulfate. Now, suppose you apply a DC voltage to 2 electrodes, then what will happen? Cu2 plus ions discharge at cathode, and then this particular reaction will take place. What happens? Cu2 plus 2 electrons, that is copper ions that is accepting 2 electrons and becoming copper metal which is deposited at the cathode. And what happens at the anode? Copper will become, it is changed to Cu2 plus ions by this reaction. Okay. Now, the copper is dissolved or oxidized at the anode and it is deposited at the cathode. So, this is the main basis for industrial process in which impure copper can be converted into high pure copper. Highly purified copper is obtained by this process in industries. The impure copper is made at anode that dissolves on passing current, and pure copper is deposited at the cathode. Do not get confused between which is going to which, anode and cathode. You have to be thorough with this. And sodium and magnesium are also produced by electrolysis of the fused chlorides, and aluminum by electrolysis of aluminum oxide in the presence of rhyolite. So, they will ask you in the presence of which reagent does this reaction takes place, remember, and the starting material is cryolite, and remember the formulas also. And voltaic cell, and already as you saw about the voltaic cells, electrons will leave the anode and flow through the wire to go to the cathode, and when the electrons leave the anode, cations which are formed, that will dissolve into the solution in the anode compartment. You can see the representative diagram here, and this is a porous barrier. You can look at this diagram. We call it a salt bridge. So, the particles can move through this bridge from one end to another, and external circuit, it is moving in this direction, that is from anode to cathode. Okay. Now, what are strong electrolytes? See, delta M increases slowly with dilution. What is meant by dilution? Adding water and diluting it, and you can show it using this equation, and you can even plot a graph against these 2 factors. You get a straight line with an intercept equal to E0 and slope is equal to A, and the value of the constant A, it is a constant for a given solvent, and temperature normally it depends on the type of the electrolyte which you use, and the charges on the cation and anion which is produced by the dissociation of the electrolyte in the solution. So, NaCl, sodium chloride, that is calcium chloride, magnesium sulfate, these are all known as, you remember this order 1 minus 1, 2 minus 1 and 2 electrolytes, 1 1 2 1 2 electrolytes, and all electrolytes of particular type have got same values for A. They will be asking you NaCl, so you have to remember it is 1 1. So, like that questions can come for the NEET exam. From each of the topics which we are discussing here, all these are very important. And again, voltaic cell, already this short I have shared with you. Now, once you determine the cell constant, you can use it for measuring the resistance or conductivity of any solution. Normally, it has got 2 resistances, R1 and R2, whatever you want to choose. You can take variable resistance R1, and conductivity cell unknown resistance normally we take as R2. And Wheatstone bridge, you would have done the practicals in your physics lab by now. It is fed by oscillator, and the source of power will be AC in audio frequency range of 550 to 5000 cycles per second, and P will be a detector, and bridge is balanced when no current passes. You have to under these conditions you can calculate the unknown resistance R2 by using this formula. It is very easy to calculate it. And first you determine the cell constant and resistance of the solution. After that you can find out the conductivity of the solution by this equation. Okay, remember this equation well. And conductivity of solutions of different electrolytes in same solvent at a particular temperature will differ by because of the charge and size of the ions in which they dissociate, that will be different. The concentration of the ions or ease with which ions move under a potential gradient, and it is therefore necessary to define a physically meaningful quantity called molar conductivity. You use the symbol like this, and it is related to conductivity by this equation. Now, there is a relation connecting both just conductivity and molar conductivity. This is the equation. Remember, you can get some simple sums based on this for your NEET exams. And quantity I by A, we call it a cell constant and denoted by this letter G. Normally it depends on the distance between the electrons and their area of cross section, and it has one dimension and the dimension length, and you can calculate it if you know I and A. And the measurement of I and A is not only inconvenient but unreliable as well. So, cell constant is normally found out by measuring the resistance of the cell in the solution whose conductivity is already known. So, if you know the solution's conductivity, it is easily we can substitute and find it out from the relation. And we use the KCl solution normally, because why you are using KCl solution, you can accurately know the conductivity of this at various concentration and different temperatures. So, cell constant G is then given by the equation G is equal to I by A, that is RK. Then electrochemical cell and Gibbs energy of reaction. So, this is another topic, and normally electrical work done in 1 second, it is equal to electrical potential multiplied by total charge. Now, you want to obtain maximum work from a galvanic cell, and then the charge has to be passed reversibly. You have to reverse the charge, and that point the reverse work done by galvanic cell is equal to decrease in Gibbs energy, and EM of the cell is E, and NF will be the amount of charge passed, and delta Fg is the Gibbs energy of the reaction. You can see this equation connecting all these factors, which is very important. Now, variation of conductivity and molar conductivity with concentration. Both conductivity and molar conductivity, many students confuse thinking that these two are the same, but it is different. They change with the concentration of the electrolyte. Conductivity will decrease with decrease in concentration, both, even if it is a weak or a strong electrolyte. How can you explain it? You can understand this fact that the number of ions per unit volume which carry current in a solution will decrease on dilution. That is, when you dilute it, the number of ions concentration that will be distributed to a large area. So, the current in the solution, that ions carrying current in the solution naturally will decrease. And the conductivity of a solution at a given concentration is conductance of one volume of solution kept between two platinum electrons with unit area of cross section and at distance of unit length. They will be asking, giving this definition and asking it is for what conductivity. This definition is for conductivity of a solution. A and I are unity, then G will be equal to K. Remember that. Okay, now what are weak electrolytes like acetic acid and all that? Their degree of dissociation will be less, then that means they are weak electrolytes. Even if you increase the concentration, the dissociation will be low only. So, for such electrolytes, the change in delta M with dilution is due to increase in the degree of dissociation and the number of ions in total volume of solution which contains 1 mole of electrolyte. So, in such cases, the value of E will increase steeply on dilution, especially near lower concentration. So, you cannot obtain by extrapolation of delta M to 0 concentration. But what happens at infinite dilution, that is concentration C is equal to 0 electrolyte dissociates completely, and at low concentration conductivity of the solution will be very low, and so low that you cannot even measure it accurately. Therefore, EM0 for weak electrolytes is obtained by Coulom's law of independent migration of ions, which says that at any concentration C, if alpha is the degree of dissociation, it can be approximated to the ratio of molar conductivity EM at concentration C to limiting molar conductivity EM0. You can see the equation here, and just remember that. That is also very important concept in weak electrolytes. Now, what is law of independent migration of ions? This law states that limiting molar conductivity of an electrolyte can be represented as sum of individual contributions of anion and cation of the electrolyte. That is, if delta 0 of sodium and delta 0 of chlorine are limiting molar conductivity of sodium and chloride ion, then limiting molar conductivity of full sodium chloride, you can get it by this equation. By adding the individual factors, you will get the molar conductivity limiting for the whole sodium chloride. Okay. Now, the inverse of resistance R, it is called R is called conductance G, and the relation you have to remember, G is equal to 1 by R, because 1 by R is the inverse of R, and that is called as G. So, that is equal to area of cross section by rho L, and which is equal to K A by L. So, SI unit of conductance is Siemens, symbol is S, and U equal to ohm. We can also call it as, reverse it, MHO, or ohm raised to -1. Then inverse of resistivity, we call it conductivity or specific conductance, which is shown by the symbol K. The SI units of conductivity are S per mole, but often K is represented in S per centimeter. Conductivity of a material, S per mole is its conductance when it is 1 meter long and area of cross section is 1 meter square. And just remember this relation between these two conversions. And with that, we are coming to the end of this session, and for your convenience, I have divided this lesson into different parts, and I will be uploading the next part at the earliest, because we have got only approximately 2 months time to complete all our revisions. Once we are done with it, I will be uploading MCQs, the most important ones, and which has come for previous year NEET question papers. We will be also discussing the previous year's NEET question papers one by one, and I will be uploading the important sums and simple tricks to easily calculate the sums, and also mind maps, which gives you a brief description for quick revision just before your exams. And as always, I say, please do like, share and subscribe to my channel, Chemistry Made Simple for NEET, and don't forget to press the bell icon, so that as soon as I post new videos, you will get the notifications immediately. With that, I am coming to a conclusion of this topic, and thanks for watching my video.